Hey guys, today we're going to start part 2 of lessons 3.2 and 3.3, and we're going to be looking at some proofs today, and we're going to cover those later in our lesson. First, I want to talk about every theorem and postulate that we have discussed this year, because these are going to be your answers to the proofs. Okay? So all of this is what I'll refer to as your answer key. All right. So looking at some of our answers here, just a quick review. Vertical angles, linear pairs, those are some things that we looked at in chapter 1. Substitution, transitive property, those are some concepts that you looked at last year in Math 1, and we'll review a little bit of those today. The rest of these theorems we have talked about in chapter 3, or will talk about today. Okay, so there's a list of all of our theorems and postulates that we'll be using in some of our proofs. Now, a few that I want to touch on before we get into our proofs are these theorems here. First, the congruent supplement theorem. It states if we have two angles, we'll say A and C, and they are supplements to the same angle B, then A is congruent to C here. I need to change that to C. And what this is saying here is if we are looking at these two angles A and B, one, they form a linear pair, so we know they're supplementary. And if we subtract the 40 from 180, we know that this angle A is 140, which would also be true for B and C. So what we're saying here is now angle A and C, because they're both supplements to B, we know that they are going to be congruent to one another, even though they're in two different pictures. They're not connected. All right, another common theorem that we may run across are the consecutive exterior angles. In our last lesson, we talked about consecutive interior angles in that theorem, and we said that those are supplementary. We also have consecutive exterior angles, and here we're using our vertical angles concept, where we know that vertical angles are congruent. So if I take the X and move it to its vertical angle, and the 115 and move it to its vertical angle, but here we have two exterior angles, and they're on the same side, which we would identify them as consecutive exterior. And their theorem states that they are supplementary as well. So just I'll show some quick work to solve for X. We know that X plus the 115 is equal to 180. And through some Math 1 solving, we will know that X is 65. So those are consecutive exterior, very similar to consecutive interior. And next is a property you learned in Math 1, and that is substitution and transitive. These are very similar, but the way that these are written depends on which property we use, whether it's substitution or transitive. So for example, in substitution, we have A is equal to B, A is equal to C. Notice that A is on the same side, so here we can substitute. With the transitive, we have B is equal to A and A is equal to C. The two A's, they are on different sides of the equal sign. So this would be our transitive property. So just a little technicality there. Make sure you know that common variable, whether it's on the same side for substitution or whether it's on different sides for transitive. Okay. So that's a quick review of all of our properties that we'll be using in theorems to our proofs. Now moving into our proofs. Proofs are a way to organize our thoughts and ideas, and we will use what we call a two-column proof. Two-column proofs, we have statements on the left and our reasons on the right. So our statements a lot of times are the definitions. The reasons, those are the actual properties and theorems that we are using. We will always start off a two-column proof with our given information, and I'll go into more detail when we get to some examples. So we'll always start out with given, and our last piece of information is always going to be the prove step. And we'll know the reason once we go through our proof. Now, when you're going through a proof, I want you to put yourself in the mind of a lawyer. Think of law, where you're trying to prosecute somebody. And in a courtroom, you have the evidence. And for that, the lawyer has to go through a series of steps. He's going to collect, or she's going to collect information in order to prove the final verdict of what they want, whether that's guilty. The prosecutor would be guilty here. So we're kind of stepping in the shoes of a lawyer for a little while. All right, so here's our first proof. So a proof that will give you a given statement, a proven statement, and a lot of times they will give you some sort of diagram to work with. So as a lawyer, here we know that our given statement is L is parallel to M, and our reason for knowing that is because it was given to us. And we know our last step is going to be that angle 4 is congruent to angle 6. So this is what we are trying to prove. We're trying to prove that this is our guilty. Now, we don't know the reason for our last step just yet. We'll have to come up with that as we go through our proof. All right. So what we want to do is we want to take this given statement and label anything that is necessary in our diagram. So we know that these two lines, L and M, are parallel. So I want to add those extra set of arrows here to indicate parallel. And we want to point out some things that we know is true about our diagram. And one of the first things we see, I hope you see, we have two angles here, angle 2 and angle 4, and we know that those are vertical. And we know that vertical angles, they are congruent to one another. So we're going to write that in our proof. So this is the evidence that we're gathering here. So our second step, angle 2 is congruent to angle 4. Our reasoning is that they are vertical. Vertical angles are congruent. Okay. Next, we also know the relationship between angle 2 and angle 6. From yesterday, or from our previous lesson, we know that those are corresponding. And we also know that corresponding angles, they are congruent as well. That's that postulate. So we can say that for our next piece of evidence, angle 2 is congruent to angle 6. Our reasoning, corresponding angles, and you can shorthand these and abbreviate them as necessary, of the corresponding angles postulate. Now that's all the evidence we can gather from our diagram. Now we want to look at our statements and see what can we do in order to prove, get that guilty verdict there of angle 4 is congruent to angle 6. And one of the things that I hope you're seeing, we have angle 2 being used twice. And we can go back and look at our substitution property. It's very similar to the 2A's. What we can do is substitute B and C into each other to where we get angle 4 and angle 6 being congruent to each other. And our reasoning is by substitution. So our last step, in the beginning we didn't know what number step it would be. Sometimes we have 3 or 4 or 5, even 6 at times. We now know that this will be step 4 and our final step. Okay. So this is our first proof, and this is actually the proof of alternate interior angles. This is the proof of the alternate interior angles theorem. Now, another way we could do this same example is that it's okay if we switch the order of step 3. In the first example, we did 2 first and then angle 4 second. It's okay if you switch the 4 and the 2 here, but notice what happens is now that angle that's being used twice, they are on different sides of the equal sign. And that will cause us to use the transitive property instead of substitution property. So just make yourself a note. Order is important, especially when it comes to substitution and transitive. One good thing about proofs is they're not always black and white. There's some gray area in there where you can kind of put your own spin on how you want to write your proof. All right, moving on to our next proof. So here you can see We have most of the 2 columns set up. And again, guys, if you need to pause this at any time to write down this information, you can pause the video and then pick up once you have this information drawn. So our given information, A is parallel to B and C is parallel to D. I'm going to represent that in our picture. We're going to add those arrows. Always add your information in your diagrams. Now here, these are more fill in the blank. So we're going to look at step 2 where it says angles 2 and 3 are supplementary. So here's our angle 2, here's our angle 3. Now we have to come up with a reason why those are supplementary. And if you look, we don't need line C for now, but if we look, we can see that these 2 are consecutive interior angles, which proves that they are supplementary. So this would be our consecutive interior angles theorem. Next, we'll move on to step 3, which states 1 and 2 are supplementary. Now 1 and 2, those have a very similar relationship. We can mark out line B because we don't need line B right now at the moment. And one of the things I've discussed in my classes is a lot of times when we're working with transversals and parallel lines, our pictures are nice and pretty where the parallel lines go left to right. So here we're working with the same thing. Our parallel lines are just going vertical. So here we do have another pair of consecutive interior angles, which states that they are supplementary. And so now we're to our last step. We need to prove that 1 and 3 are congruent. So we need to state that 1 and angle 3, those 2 are congruent. And this is our new theorem that we covered today. We can use the congruent supplement theorem, where we have angle 3 is congruent to 2, angle 1 is congruent to 2. So because both of those are they are supplementary. 3 is supplementary to 2, 1 is supplementary to 2, and because they're both supplementary to the same angle, we can prove that angles 1 and 3, they are congruent. And we're using the congruent supplement theorem here. So all the definitions and all those theorems that we've talked about and you studied, they're really coming into play in Chapter 3 as well as Chapter 4 when we're talking about proofs. Okay. In our next example, it's the same diagram, but we're going to talk about how there's different ways to skin a cat. There are multiple ways to get the evidence that we need. So we're going to start at the top here. We have our given. So we're going to write down our given. A is parallel to B. C is parallel to D. And our reasoning that was given to us. I'm also going to add those arrows in here So we can indicate parallel. Now for this example, in our previous example, we used angle 2 as sort of a bridge to connect 1 and 3. Here, let's avoid using 2. Let's try to use angle 4 to connect the bridge between 1 and 3. And one of the things that I see, and I hope you're seeing this as well, is that angles 1 and 4, the connection between those is that they are alternate interior. So we know that angles 1 and 4, they are congruent because of our alternate interior angle theorem. So we've connected the bridge between 1 and 4. Now we need to connect the bridge between 4 and 3. So 4 and 3, these angles are in the same position. And when we have angles in the same position, that means they are corresponding. And with corresponding angles and parallel lines, we can say that angle 3 is congruent to angle 4 through the corresponding angles postulate. So we've connected the bridge between 1 and 4 and 3 and 4. Now we can connect 1 and 3. And as we look at our evidence, I see that 4 is on the same side. So we can substitute here and say that angle 1 is congruent to angle 3. And our reasoning is a Math 1 topic, substitution. All right, moving on to our next theorem, we have our given information. Our two lines of L and M, they are parallel. So we'll write that in our two columns. This is a great, two column proofs are a great way to organize your information. And we're going to put parallel in our picture. And our goal is to prove that 3 and 6 are supplementary. So we're trying to connect 3 and 6 to one another. So that's kind of what we want to keep in mind in the back of our head of what we're trying to prove. We're trying to get that guilty 3 is 6 being supplementary. Okay. So one of the things that I see is that 2 and 3, they are adjacent and they form a straight line. So we can connect 2 and 3 together and say that they are supplementary. Angle 2 plus angle 3 is equal to 180 degrees. And our reasoning is that they are a linear pair, two adjacent angles whose non-common sides form opposite rays, making them supplementary. So that's that those definitions coming back from chapter 1. Now I'm also going to connect or bridge 6 and 2 to one another. In chapter 3, we know that those two angles are congruent because they are corresponding angles. Now, what we're going to do is we're going to use our information here. And what we're going to do is we're going to take this 6 and substitute it in for the 2. Because remember, we want to get 3 and 6 together. So for our fourth step, we're going to say that angle 6 plus angle 3 is equal to 180. And our reasoning there is we substituted that 6 in there. And now we can write our proof step. Because 6 and 3, their sum is 180, we can say that those two angles are supplementary. And our reasoning is that's the definition of supplementary angles. And now we have our proof, just like they've asked. We have found the guilty verdict. All right. So proofs are going to take a lot of practice. The more you do, the better that you will get at these. All right. And the different techniques of how to get that guilty verdict. Now, I want to move on to the second part of our lesson, which we're working with the converse. In the converse, remember, we are proving parallel lines. So before we started with parallel lines, now we're going to try to prove parallel lines. So I want you to think more on the converse side. So in our first example, given, we have that angle 4 is congruent to angle 6. Our reasoning is that it's given to us. So I'm going to state that, represent that in our diagram, 4 and 6 are congruent to one another. And we're going to use our sort of our bridge method here, where we're going to try to bridge 2 and 4 and 2 and 6 here. The first relationship that we see, angles 2 and 4, those are vertical. So we know that they are going to be congruent, because vertical angles, they're always congruent. Now we can actually look at our information here, and we can use our statements to bridge our 2 and 6 gap that we were discussing earlier. And using that information, we can say, okay, I noticed that 4 is being used twice. So I know that angle 2 is congruent to angle 6. And we're using our transitive property. I said substitution. We're using transitive because that angle 4 is on different sides. If we switch the order, so I'm going to go over here to the side. Let's say we switched the order and used angles 2 and angle 4, then that would have been substitution. So again, that order is one, excuse me. If we did angle 4 is congruent to angle 2, then that would lead us to substitution, because 4s would be on the same side. Now what we have done is we have proved that angle 6 and angle 2, they are congruent. And if we go back to our previous slide, if corresponding angles are congruent, then our lines are parallel. So what we have done is we have now found our guilty verdict. We know that L is parallel to M because of the converse of the corresponding angles postulate. So anytime you see in your examples that you're trying to prove parallel lines, a lot of times you will be using a converse instead of the original postulate or theorem. Okay. All right. What I'd like for you guys to do is take a look at the practice, work with these theorems, and get comfortable. You might need to go back and study some of these theorems and postulates from chapter 1 and earlier in chapter 3. If you have questions, please get in touch with me. You can email me, or we can set up a meeting to meet through Google. All right. You guys have a good day.